This question is jump game 4, and essentially what you have to do is you have to start from index 0 and you have to go to the last index, and you have to compute the minimum number of steps to reach the last index of this array. Now there are 3 legal moves. Firstly, you can go +1. Secondly, you can go -1, or you can teleport to the same value of any index within this array. So if you're at 404 over here, you can teleport to the last index, which is 404. So the way the code is written is you start with getting the dimensions of the array, so n equals to length of array. Then you have a base case, which means if there's only one element within this array, you just return 0. Then you start with building the value map. So it's a one pass over the array. You record where each value lives. So enumerate will give you index and value together. And this is what makes the O of 1 do lookup instead of requiring a fresh scan of the array from every node. Then you have your BFS setup. So this visited will prevent revisiting indices. So it's a list of pools indexed by position, and it's faster than a set over here. Then you are setting the visited of the first index of the 0th index to be true. You have a queue, which is a double-ended queue, and you're seeding it with index 0. And then you have a used set, and your steps to begin with are 0. Now you will iterate through the queue. So while there are still elements in the queue while it's not drained, you start with a for loop. So for I in range length of the queue, you pop the first value, assign it to be the variable I. Now you are checking if I equals to n minus 1, which means if I is the last element, you return the steps. That's the end of our loop. If not, then you have another check. Now, if this area of I is not in used, so the value at the index we just popped. Now, used over here holds every value whose group has already been expanded. So this is basically asking that have I already teleported through this values group at some point earlier in the search? If yes, we will skip this whole block. If not, then in this used, we mark this to be added, which means we are marking this value spent immediately before doing any of this work. So from here on, any other index holding this same value will fail the guard and skip straight to this walking moves. Now for j in groups of this array of I, so this is the pre-computed list of every index holding value, this value, so value array of I. Now these are exactly the places you can teleport to in one jump, and walking this list is the reason the map was built in this phase 1. And without this, we would need to rescan the whole array from every node. And then it's checking if not in visited j, so it only takes indices we have not reached yet. So an already visited index has a smaller or equal distance. So requeuing it could never improve anything, and we would loop forever. And that's why we have this check. We mark visited of j to be true, which means we are claiming it, and then we are over here queuing it. If we don't go through this, then we are going to go through this. So this is the walking move. Now this is checking if walking is possible. So this is the same as jump game 3. We are checking if we are checking for two positions, which means I minus 1, I plus 1. We have a bound check. If this has not been visited before, then we mark this. We are again claiming it and then queuing it. We mark this as true. We append it to our queue. And then we, at the end of this for loop, within the while loop, we increase the step by 1. And if it's not possible to get an answer, then we just return -1.